Okay guys, the title for today's video is going to be Balancing Redox Reactions. Alright, so here's your title. As you remember, this is a continuation from today, but in the video I'm going to try and go into a little bit more detail, okay? Okay, so let's get started. So a balancing a redox reaction, or a redox reaction, is just an abbreviation for reduction and oxidation reaction. Okay, the reaction is characterized by a transfer of electron density from one atom to another. Now, I know what you're thinking, hey mister, what does that mean? Well, let's take a look, right? Let's take a look at electron density first. So let's say I have a sodium atom, right? And I have a chlorine atom, all right? Now, around these guys, okay, I have certain number of electrons. For example, around sodium, I have one valence electron, and around chlorine, I have 1, 2, 3, 4, 5, 6, 7, right? Okay, now looking at these two electrons, right? Looking at these two atoms, right? Which one between this one and this one do you think is going to have a higher electron density? Well, and between these two, here's what's happening, right? So the one that's going to have the higher electron density, right? Obviously, in this case, it's going to be the chlorine, right? This one right here. This guy has a higher electron density because it has more electrons, right? So this is what we're talking about, electron density. Now, when we're talking about transferring electron density, what we're saying is that, an atom here or here is going to transfer its electrons either this way or this way, right? But here's the deal, right? Going back to review, we know which one of these guys is going to oxidize and which one is going to reduce. For example, we know that because sodium has this one extra electron, right, it's going to be easier for this guy to give away an electron than it is going to be to try and pick up 7 more. So we know that sodium will oxidize, right? This is our review. And like I said, because chlorine just needs that one more electron right there, it's just going to try and pick up one electron as opposed to try and get rid of all 7 of the ones that it already has. So we know that chlorine is going to reduce. So because one is oxidizing, right, that we see here, and the other is reducing that we see here, when you have a chemical reaction that involves sodium plus chlorine produces 2 NaCl, sodium chloride, then we characterize this reaction as a redox reaction. Now, we went over this one in class today, so I'm not going to do this one again, okay? So, but we know that this is, in fact, a redox reaction, right? So what I'm going to do now is I'm going to go ahead and I want you guys to pause the video for a second. All right, make sure you take down all this information, and then I'm going to go ahead and do another reaction to show you exactly how to balance a chemical redox reaction. Okay. Okay. So here's a new chemical reaction. All right, it's a synthesis reaction between calcium and oxygen, and I've already gone ahead and balanced it for us. Okay. Now, this also is characterized as a redox reaction, but let's try and figure out why. Okay. This is a point where if you don't have your oxidation rules, go ahead and pause the video. Make sure you get those out because you're going to need those for this next part. Now, looking at your oxidation rules, if you've already gotten them out, okay, you would know that calcium has a 0 charge, right, because it's an element in its natural state, and O2 also carries a 0 charge because it's an element in its natural state, right? Now, what happens as you go from calcium to calcium oxide? What's happening to the calcium? Well, I know that it's ionizing, right? Ionizing means that it's becoming an ion, right? Now, when it becomes an ion, that means that it's going to be an element that now carries a charge. So in calcium oxide, what's the charge of calcium? Well, I know that calcium carries with it a 2+ charge, and oxygen carries with it a 2- charge, because from here to here, oxygen is also ionizing, right? Now, this has to do with the fish, right? Remember the fish? Calcium, 2+, oxygen, 2-, right? This number becomes the number here. This number becomes a number here. And because they're both the same number, right, you just write it as CaO, right? But in order to form this compound, you first have to form ions. And these are what we call ions, elements that carry with it a charge. Okay? So, now we know from here, let me see here. From here to here, right? We're seeing that calcium is ionizing, becoming an ion, right? How does it do that? Well, we're going to get to that in just a minute. And from here to here, right, oxygen is also ionizing, right? But how does it do that? Is it oxidizing? Is it reducing? Well, let's figure it out. Okay, so I went ahead and cleaned it up a little bit, and we're going to determine which one is reducing and which one is oxidizing. So I'm going to put the charges back up right here. All right, 0, 0, 2 plus, 2 minus. Okay, so from calcium 0 to calcium 2 plus, did calcium pick up electrons or did it drop them off? Well, calcium, right, has an atomic number of 20. So that means that it has 20 protons and 20 electrons. Protons carry a positive charge, electrons carry a negative charge. So when you subtract these, you should end up at 0, which is where we get this number right here. Okay? Now, to go to 2 plus, right, calcium actually gave up 2 electrons. So it has 20 protons, but now instead of 20 electrons, now it only has 18 electrons. So because now it only has 18 electrons, it ends up with a net 2 plus charge. This process is what we call ionization. Right? This calcium gave up 2 of its electrons, the 2 valence electrons, right? Let's see here. It gave up its 2 valence electrons, right? Took those 2, gave them away, all right? And because it gave up its 2 valence electrons, now it only has those 18. And because now it has those 18, it ends up with a net 2 plus charge, right? Again, this is all review. So if calcium gave away those 2 electrons, right, is that considered oxidation or is that reduction? Well, we call that oxidation. Right? Okay, let's take a look at the oxygen now. Right? The oxygen is the same kind of principle. It goes from a 0 to a 2 minus. Right? It's the same principle that we just explained right here with the calcium. Right? Same thing, except now it has a net negative charge. Right? So in this explanation, oxygen is actually picking up electrons. So because oxygen is picking up these 2 electrons, right, we call this reduction. We call this reduction, right? So in this reaction, or this redox reaction, right? In this redox reaction, we have something that's oxidizing and something that is reducing. Okay, so because you have something that's oxidizing and something that is reducing, then we call this an oxidation reduction reaction. All right, these things always happen together. So write that down. Always happen together. Right? You cannot have something oxidized, right, without having something there to reduce. You cannot have something there to reduce without having something there to oxidize. Okay? Go ahead and pause the video. All right. Finish writing this down, and then I'm going to clean this up, and we're going to go ahead and start working with balancing the redox equation. Okay, nice and cleaned up. Hopefully you guys got all that stuff written down. If not, you can always rewind the video, pause it, and finish it up. Okay, so now we've established that calcium is your oxidizing, right? Is oxidizing, and we know that oxygen is reducing. So when we take a look at these guys, we know that this guy is going to be the oxidizing, right? And because calcium is oxidizing, we call it the reducing agent. Hey, wait a minute, mister. Why is everything always got to be backwards? Well, it's not that it's backwards, but what's happening is because calcium is oxidizing, it's allowing for oxygen to reduce, right? And because oxygen is reducing, it's allowing for calcium to oxidize. So because oxygen is reducing, we call that the oxidizing agent. All right. So just always remember, if it's reducing, it's the oxidizing agent. If it's oxidizing, it's the reducing agent, right? So reducing, I'm going to just abbreviate with R, right, is your oxidizing agent. Okay. And whatever's oxidizing is your reducing agent. Just remember it like that, is your reducing agent. All right. Go ahead and finish this up. I'm going to clean this up one more time, and then we're going to go ahead and start balancing. Okay, nice and cleaned up. Let's go ahead and just move this up a little bit. Okay, in order to balance a redox reaction, you have to break it up into what we call half reactions, right? There's two halves to every reduction, right? To every oxidation reduction. In this case, the half reactions split up very simply. One half is your oxidizing reaction. And the other half is your reducing reaction. All right? It's not very complex. I mean, you have an oxidation reduction. I'm going to abbreviate reaction. Oxidation reduction reaction. So if you have oxidation and reduction, then half of that is oxidation and the other half is reducing. All right? So I'm going to draw a little line here. And we're going to go ahead and do the first 1/2 reaction. So let's do the oxidizing reaction. Right? We said that the calcium is your oxidizing reaction, right? It's your reducing agent, but it is your oxidizing reaction, right? So now we're going to only work with the calciums, okay? So let's take a look. Calcium, right, becomes calcium 2 plus, right? Now, calcium is going from a 0 to a 2 plus. How do we balance it? Well, this is the important factor right here, right? Calcium has a 2 plus charge. In order for it to get there, we said before that calcium oxidized, and because it's oxidizing, that means that it's giving up those 2 electrons. So how do we balance it? Well, it's very simple. We balance it by adding 2 electrons. Wait a minute, mister, I don't get it. Well, let's take a look. If I have calcium, all right, and calcium has given up those 2 electrons, at least here it has, right? By adding 2 more electrons, right? By adding 2 more electrons, according to this, right, then we get back to this 0 charge. Because, look, what you're saying is now you have calcium that had 18 electrons, right? And you're making it to where it has 20 again. So where it went from a 2 plus to a neutral charge, right? So we balance the reaction, right, by adding 2 electrons right here. You add those, really this is what you're saying. See? You have a calcium with no electrons getting 2 added to bring you right back here. So this is balancing by adding electrons, right? Okay, go ahead and pause the video. Go ahead and write everything down. I'm going to clean everything up, and then we're going to do the second half. All right, second half of the reaction. Now we're going to do the reducing reaction. Okay, I'm going to abbreviate reaction. All right, so here's my reducing reaction. Now we're going to be working with just the oxygens. All right. All right, here's what we're saying. We're saying that O2 becomes O2 minus 2, right? Now, why do we add the 2? Why did we add this 2 right here? Well, remember, you have to balance these 2. If you have 2 oxygens here on the reactant side, then you need 2 oxygens here on the product side, which is where this 2 comes from. All right, so I'm going to erase these little lines here. All right, there we go. Now, we said earlier that this is a reduction reaction. So what's happening is that these two oxygens over here, right, have actually picked up electrons. Now, we can't subtract electrons. We can only add electrons. So how are we going to write this so we can balance it out and get the 2 electrons there? Okay, so let's try it right here. O2, right? I'm going to add the arrow, and I'm going to put my 2O2 minus. How many electrons do we have to add to get to this 2 minus charge? Well, the answer is very simple. It's here. I have to add 4 electrons to balance out this reaction. Whoa, mister, you can't just throw 4 electrons out there and not explain what's going on. Okay, so I'm going to clean up a little space so I can show you exactly what I'm talking about. In fact, let me see if I can just shrink this. All right, shrinking now. There we go. I'm going to put this over here so you guys can still see it. Okay, so, mister, what's up with these 4 electrons? Well, here's what's going on, guys. All right, we said earlier that O2, right? Let's take a look at O2. There's 2 oxygens, right? Going back to the beginning of the year, how many valence electrons does oxygen have? Well, oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 valence electrons. That means that each oxygen, right, has 6 valence electrons. Now, if we're going to reduce, okay, that's what we said up here, we're going to reduce, it's still there, okay, that means that each one of these guys has to get those 2 electrons. So, what we're saying is this. This oxygen here on the left got 1, 2 electrons, and this oxygen here got 1, 2 electrons. So because each one of these 2 electrons, right, received, 2 oxygens received 2 electrons, then we have a total of 1, 2, 3, 4 electrons added. So when you balance the equation, this is what you're saying. You're saying that O2, right, these 2 guys right here, little check marks here, had to receive, right, had to receive 4 electrons, right, in order to balance itself out to get 2 oxygens, right, each with a 2 minus charge, right? So here are our balanced redox reactions. We have 2 half reactions, right, that are now balanced. So let me go ahead and take this one, shrink it down even more, all right, and I'm going to write my 2 half balanced reactions. My first one we said was calcium, right, goes on to make calcium 2 plus 2 electrons. Okay, and the other half reaction is oxygen, O2, plus 4 electrons to produce or to yield 2 oxygens each with a 2 minus charge. And this is how redox reactions balanced. All right. Now, keep in mind, guys, that you can pause this, you can fast forward it, you can rewind it. Go ahead and take a look, all right, at the reaction. And then here's a couple of practice ones that you guys can do. I'm going to clean this up here. Okay, guys, here's a couple of practice redox reactions you guys can balance out. I want them in this format right here. Okay, balance out the half reactions, and I want you guys, obviously I've only given you the reactants, so you have to find products, right? So find the products, balance the equation, and balance half reactions, right, using electrons. All right, guys, this is it for the video. Go ahead and give these a try, and then as the day goes on, as the week goes on, we'll go ahead and start doing some of these on the board. All right, don't stress over it. It's not as hard as it looks. If you have questions, you know where to find me. All right, guys.